Hello again, and thank you for joining us. I'm thrilled to welcome our next group of speakers, Ken, David, Francis, and Ahmed, to our final Q&A session for today. I really appreciate all of the speakers for taking the time joining us. Before we get into the questions, I'd like to remind the audience that if you can continue to post questions on the @Scale conference link, and we will pull questions from that. So we do have a few questions, and let's get started. So the first question is on the large scale data graph for Ken and David. Could you speak to what was your biggest challenge when building the data graph?
I need to remember to unmute as well. Yes, so I can take that one. Meta has a very big diversity of systems and data processor. And each system has its own idiosyncrasies and are actively worked on by our engineering community. But there are always some corner cases. So gathering the events and being able to deal with all those corner cases can be a challenge as well. Another challenge when building the data graph is to provide a precise measurement of accuracy and coverage for each system. This is very important as we set the bar very high for all our application. And finally, I would like to bring another challenge, a last challenge, which is around the boundary expansion. With the boundary expansion, we are looking at sometimes partial and incomplete information. And merging them together to form a more accurate and complete picture can be a challenge. There's a lot of data analysis, data analytics going on in there. But over time, this really form the backbone of building a complete pictures that is useful for all our application.
Awesome. Thank you for sharing. I guess the long tail of use cases is equally critical as the first 80%. The next question that we have here is, thanks, David. The next question we have here is for Francis. Can DuckDB be used as a data warehouse?
The way I think of a data warehouse is it's really giving you the idea of infinite storage and scalable compute. That's really not what DuckDB itself was designed for. DuckDB was specifically intended to be an in-process, embedded within a single process. I think what MotherDuck does then is try to build enough of that framework around DuckDB so that you can use it for the collaboration, for the scalability that you would get with a data warehouse. So I think that's really where MotherDuck partners with DuckDB and extends its capabilities.
Got it. That makes sense. Thank you. The next question we have here is for Ahmet on the Beam ML. How much of an improvement do you see from GPU efficiency improvements?
Yeah, hi. So we actually see a great deal of improvement. So what we have seen was that I guess there was a lot of low-hanging fruits in this type of workloads where people are mostly focused on getting something out first. We are seeing up to 3x efficiency improvements. We are seeing, when we look at fleet-wide metrics at Google, and we do have a large enough fleet, we are seeing the efficiency improving from lower to 20% to up to 60%. That's incredible in an era where GPUs are hard to get, and when you get your GPUs, you're not utilizing them.
And the abstraction is making it a lot easier, from a usability perspective.
Yeah, that was our goal. So can we get it out of your way so that you don't need to think about it, and we can solve this once and for all for you.
That's awesome. Cool. The next question we have here is on the large-scale data graph. On the policy decision point, what is the interface that it provides for other systems to integrate with?
Yeah, so let me explain. This is a good question. Let me explain a little bit. So we provide both the query-based API and the object-based API. So for query-based API, we mean the service accepts a query and then answers whether the access is allowed or not, and when it's not allowed and why it's not allowed. And we also, for the object-based query, we mean it accept a list of objects such as tables and the columns and make the same decision. So we are moving to the direction of increasingly use more and more query-based decision, because query provides higher level context, and the higher level the context and the better and effective decision can be made.
Awesome. Can't wait for when we start integrating this with Gen AI as well in the future.
Yeah.
All right. The next question is on for Francis. We hear a lot about Iceberg and Delta Lake. What are your thoughts on those? And does DuckDB support them?
So just, adding some context for folks, those are really standardizing the way in which we're storing the tables in a database, right? And what that does, databases can already read from different file formats, ingest that data. But if we standardize how the data is actually stored, then that's going to let different compute platforms interact with the data in the same way, without having to copy it back and forth and so on. So I think this is a great trend, right? And so DuckDB, I believe, supports Iceberg now, and I think as of the 0.10.3 release, will support Data Lake. So those things are coming along, and I think from a collaboration perspective, data needs to be everywhere, and being able to collaborate and work with different data sources is so critical. I mean, I think this is a great trend. And that's absolutely where we want this next generation of tools to be going, because data without collaboration isn't useful.
Yeah, I agree. I think the glues are, building the glue is important for more standardization. It's awesome. Thanks, Francis. The next question here is for Ahmet on BeamML. What is the overhead cost of some of the usability features?
Yeah, okay. Excellent question, because you want to know what you're paying for, all the conveniences. I guess the truthful answer would be some, in the sense that what we do is nothing more than using the same building blocks in patterns that, in an opinionated way that we think that makes sense. There's no overhead of using these patterns and blocks compared to using these blocks directly. The overhead comes from the fact that we make some opinionated choices of making these reliable and better ever handled. And these are the things that, in a system where it's not a production system, one can omit, and they can potentially get a better, efficiently running system. But at the same time, what we see in most production systems, they will be eventually bundled up, and they will not be bundled up in the best, most efficient ways either. Even all of that said, I think we are looking at usually insignificant amount, less than a few percent of additional overhead compared to using these things out of the box without any additional patterns that we provide.
I'm assuming the GPU efficiency improvements kind of,
right, exactly,
more than make up for it.
Yes, it does.
Cool. The next question is for Can and David. For the iterative discovery, is it human driven? And what is the cycle? How long does it take for each iteration?
It's a great questions. Maybe I can take that one. The data graph already gathers a very large amount of information about our systems and our data flows. But it is very much a work in progress, and we are continuously working to improve both the accuracy, completeness, and the freshness of this data. It is important also to note that we target a pretty high bar in terms of those metrics. And to achieve this bar, we found that we need to keep human in the loop. We do rely on subject matter experts to adjudicate when the confidence is not high enough, and we need this extra help. And we use this information given by our SMEs to feedback loop into our graph and to improve it. But over time, as the data graph continues to improve, both in accuracy and in coverage, we expect that the need to leverage those SMEs will decrease. So for now, it's more like going slow to go fast. And those iteration typically takes a couple of cycles, maybe a few days. Being able to go across the whole graph Really depends on each use case. But it is within the order of weeks at the moment. We really looking to reduce this time and to make it more automatable over time as the confidence and the accuracy improve.
Yeah, that the moving slow to move fast later, that part really resonates. Cool. We have more live questions coming in, so let's keep this going. The next question is for you, Francis. With Mother Duck, when you store the working set data at the edge, as in on the client node, what are some of the security implications you need to deal with?
Yeah, absolutely, right. Data security and knowing where your data is absolutely critical. So I think there's two different sort of things I'd say there. One is, as the data is in transit, as the data is stored, you following your usual expectations of encryption are absolutely important. And then there's also which users, right, are able to access that data. So DuckDB starting, being completely local, didn't really have a notion of different permission models, different levels of access sharing. That's one of the places that Mother Duck is coming in. Right now, we have a very simple permission model where you're able to share read access to your data with anyone or with anyone in your organization. And we'll be building out, more of that as we go, but both controlling who's able to see what portions of the data and then how the data is, stored in transit and at rest.
That's great. Thanks for sharing that. The next one I have here is for Ahmet on BeamML. It feels Apache BeamML is designed to work with data streams. Is there any workaround for data at rest without having to build the plumbing infrastructure to convert the data at rest to data streams?
Yes, there's a workaround. The workaround works out of the box. Frances will love this question because Beam stands for batch and stream, which was a shortened version of both. It actually works with batch and stream pretty coolly. The fault is on me that I was selling the streaming part of it a lot more because I see a lot more, increasingly a lot more streaming use cases. But reality is most of our BeamML customers are actually using BeamML with data at rest. There's a lot more data at rest, and we are seeing increasingly more and more data at rest. And so what they, the person asking this question, what they have to do is literally nothing. The same thing will work for data at rest and streaming data.
That's excellent. Cool. Now a question back on the large-scale data graph. How do you do row level and column level access control in the metadata graph?
I need to let me try to answer it. So first of all, the column level access control, right? We have integrated with major computer engine systems and passing all the detailed object level information. So for example, for queries that run in the system, that basically when the decision reaches the policy decision point, we know what are the columns being accessed. We actually support even finer and granularity access control than column level. We basically support the subfield level and the access control. And for the row level access control, we supported it for specific certain use cases. And we allow the data to be defined as certain columns to be defined as guarding column and have policies associated with those guarding columns. And so then those policies are evaluated at runtime, and so only certain columns, certain rows can be accessed in those contexts.
Got it. So it's based on the predicates.
Yeah.
That's super helpful. Thank you. The next question we have here is for Francis on DuckDB. What is the sweet spot for DuckDB use cases, and when would you not use DuckDB?
I think DuckDB itself, by being designed to be in memory and embedded in a single process, not aiming to chase the largest data sets, right? Starting from the assumption that many data sets are going to be smaller than the terabytes and petabytes that people sometimes think of when they say big data. Now, as to what the actual limits are in terms of size, I think, DuckDB is at version 0.10 free, right? Still moving towards a 1.0 release, still growing, still improving. So I think we don't have a hard limit there on exactly what, working data set sizes it can handle. But, when people come to Mother Duck, we're telling them on the order of terabytes, smaller numbers of terabytes is something that's totally good for us. Larger than that, we're going to, maybe this isn't the right place to start and to play. So I think that's one thing, right? The data sizes are never intended to be the largest, right? But there is, again, a huge set of use cases that only use smaller sizes. And then I think the other thing is, particularly when you can get those interactive speeds, right? That's where I think DuckDB and MotherDuck really shine, is when you want to have that interactive feel and be able to get those real-time, not just quick results, but results that involve interactivity.
That's great. Yeah, I think most of the time we end up using a portion of the data, and we're working and asking more questions about that that data set. Cool. We have more questions. So the next one is for Ahmet. Can we use Apache Beam on top of Apache Spark or both in parallel?
Yes, you can use it. And if you go back to the data at scale 2017, you will see this graph about how Beam runs on Spark, Flink, and etc. It actually works pretty well. Most of these features works out of the box. And to give a list of customers that I know, for example, Yelp uses Beam ML on Spark. LinkedIn uses Beam ML on Samza. If I remember correctly, Lyft uses BeamML with Flink, and all of these are, I can talk about here, all of these are public blog posts that you can find and get even the architectural details. The piece that would be different is, I've broken this product called Cloud Data Flow, which offers a service. There are parts that these services will differ in certain ways, right? That running Civil Spark means that you will have to go through a different set of configurations, you will have a different set of cluster. At Cloud Data Flow, what we offer is Google's cloud services. So BeamML will work exactly the same, but if there are parts that is dependent on the service provider, how these things are built, what types of hardware you have access to, those things will differ between service providers. But to answer the question here, we have BeamML running on hybrid environments, cloud, on-premise, and with different types of execution systems. It works, and if it doesn't, please find me.
Ton of flexibility built in. Cool. I think we'll maybe have time for the last set of questions. This is back to the large-scale data graph. In the end-to-end workflow, you talked about two types of events. There's the data flow event and the identity-based access events. Could you explain why we needed both?
Yeah, so maybe I can take the first part, and Ken, you can take the second one. So for the first part, each data processors will send events that at a minimum describe what is the source, the target, and also give us a picture about what is the transformation being used. There's also extra information that can be added depending on the system, but these events are very critical to build the final graph in the most accurate and complete manner. So those events for the data flows constitute the backbone of the graph. I'll let Ken provide more details about the identity-based event, which provide a different type of picture.
Yeah, thanks, David. So I think the basically the identity-based event, right? They complement the login-based, because for identity-based, when we don't get to know that all the details and of the transformation, such as what query being run and also the finest granularity, but it actually provides a very high accuracy signal at the coarser granularity, and then which allows us to complement the graph and make the graph complement. Even in some cases, we may not have the fine detail.
So it's like taking a bunch of pictures and then reassemble them into a complete one.
Exactly.
It's a good analogy. Right. The next question here I have is for Ahmet. We have data engineering teams using Java. Is BeamML limited to Python?
Yeah, okay, that's a great question. I think the landscape of the users significantly shifted over the last 5-10 years in the data engineering space. Like 10 years ago, a bunch of Apache projects were coming out. I think it was all in Java, right? And nowadays, clearly, most of ML projects are in Python, but there are groups of people who prefer different things. And we have a focus on usability. So what we did was we made all these languages work seamlessly in the same type of pipelines. And this may sound like not a useful feature. You're a single person writing a pipeline, but it becomes extremely useful when you have teams that one team is focused on one part of the infrastructure and another team focused on another part of infrastructure. They have to share, they have to build together. So we made it really easy to build these things in Python and Java and a number of other languages which are more niche that we are supporting. And the other thing that we are seeing, that I've significantly seen this in users, that they go another level of abstract, that they build YAMLs and etc. that even takes the Pythons and Javas of the world and some form of a declarative way of running pipelines. Beam supports that out of the box. So language should not be a barrier. So that's what we are working on by working on the usability.
That's awesome. All right, folks, that's all we have for today. I'd like to thank all our speakers again for joining us, and have a wonderful day.